pretty geometry stuff.
Groovy. All right, the thing has been hit. Hey guys, what's going on? Welcome everyone now and maybe viewing temporally in the future. This is what we have dubbed the Cosmic Council. I am joined by my panelists, Jennifer Sharp from the Church of Entropy YouTube channel, as well as Akali Fisher from the Kali Fisher YouTube channel, progenitor of neutron decay cosmology. Hey, Tinkle, Rick, what's going on, everybody? Oh my god, I got more people than normally watch me now. Must be because of the ladies, obviously. But hey, I'm competitive. But the whole gist of this is I've seen a lot of folks talking about councils of this, councils of that. It's like, well, I like having discussions. And a lot of times I just kind of keep my things. It's like, here's my point. Doesn't really matter if there's an audience or not. It's okay. I still love y'all. But I just kind of get my ideas out there. So I have them out there. And if anyone else finds it useful, that's cool. But I'm actually curious because we've had some one-on-one discussions, myself with Jen, with Kale before on the channel, and I'm like, let's start bringing some different folks together. I invited a few other folks, couple other folks. They weren't available for this particular weekend, but I'm kind of getting folks that I've drawn inspiration from because I totally know I've learned stuff from both of you ladies right here. So it's like, thank you for that. And all we're trying to figure out is what might be going on. That's the generalized topic, and the more and more I learn, I go back to some of Kali's stuff, some of the things that Jen has taught me, and I'm like, damn. I find myself coming to the conclusions that I was told before that I'm like, well, I don't necessarily see how it works. I think I'm slowly starting to see how it works. Oh, we got Apex as well. Hey, thank you for joining, my friend. But how about this? There's a lot of hubbubs right now. Some would say we're in, well, I would claim we're in the middle or starting the fourth great industrial revolution. There's a lot of change going on. A lot of folks are concerned about that change, and we should have concern. But I have hope that if science helped get us into this, science can help get us out of this. That's my claim. And yeah, we were talking a little bit backstage before about some of the history. How about the first thing? Why don't we kind of go around the horn and let you ladies introduce yourselves to the folks if they haven't caught some of your other previous work?
Jen, you
Yep.
first.
Jen?
Thanks, memes. Thanks, Callie. Nice to see everyone in the chat. Hope everyone's having a great Saturday night. I've been working on various things. Like I started into what I'm into now based on wanting to bring people closer to God by basically proving God. As you can tell, I've, you know, possibly, I don't want to say failed in that, but it was more about proving it to myself. And the way I did that was with quantum periodic table. I'm sure memes has seen it a million times. That image.
One quick. Sorry to interrupt you, Kale. I think we're getting a little bit of feedback from you. I'm not sure if you happen
Really?
to have any headphones or anything like that. Maybe just load a bomb just a tad. It's a little bit of echo. It's usually when I'm talking because I'm very loud. Sorry.
Weird. No, I can't see anything. I'm just in a really ringy room.
No worries. Always continue, Jen. Sorry.
Italian
Could it be
household,
me?
tile floor. What can I say?
I maybe. I
Could it
don't
be
know.
me? Because I
I
have
see
a
headphones.
dehumidifier on here, but
No,
it's like a
it's
hum.
the audio
That's
from the
not it.
stream. I
Oh, the stream audio is coming through. Okay, that's
maybe
not
it's
me.
just
Then
me.
I've got headphones on.
I'm just a crazy person.
Ow. Okay, how's that?
Can you hear me now?
Yeah.
Beautiful.
Yeah, I don't hear
100%.
the background noise anymore.
Okay, I got you now.
Sorry, Jennifer. Continue. Apologies.
All good. So I came up with the quantum periodic table as a way to demonstrate that God is perfect, and showed that to a lot of people for a while and talked to them to kind of see where they're at, because a lot of people don't think about science in a religious context. So it was kind of bringing that all together and having a lot of community discussions to see like where people were at. Am I still coming through okay? Because I'm trying to load an image and I'm noticing my computer's like having trouble with that. So I just won't load it right now. I'll get the quantum periodic table up in a minute. Anyway, I worked on that, and that was going on 10 years ago. I got that. And then since then, I've just basically been studying philosophy and trying to present my ideas in a way that I don't know exactly how consistent they are with Western philosophy, because there's only so much consistency that you can really get, because the starting points are very different, although there are some similar things that come up and conclusions that get drawn. So that's mainly what I focus on, is the philosophy of orthodox non-dualism and how that relates to science, and how we could use non-dualism to get a framework for science that works to help us understand consciousness, which currently is not understood by science. And my methodology and system of thought allows us to treat consciousness in a scientific way. So that is what I'm bringing to the table now. And Reams and I have been talking about the mathematical frameworks related to a discovery of Thad Roberts for a while now, which I think is extremely important in visualizing and understanding the tenets of non-dualism. So hopefully we can get into that at some point. Thanks.
Groovy. Thank you so much, Jen. Now, Golly, take us away. Give us a little bit of the background.
Yeah. No, but actually, can we just like jump right into playing off something that Jen
Oh, yeah. No,
about?
please, go for it.
And because I'm really curious, Jen, about your like conception of creation of self-identity, how that plays into, like us as really a collective being, because we're not just us. There's a lot of people that live here with us, in us, that somehow all sum into this thing that we think of as being us, right? It's like your gut biome tells you something. It's really the bacteria in your stomach telling you something. So they're deciding, and they're sending you a message that's going to make you do something. And it's really not of your volition anymore. They have hijacked your body, and you just deal with that sort of thing. So it's just like, I find that interesting. And I've developed a sort of like a core physics principle of how to get identity. And I was just curious as to like where you are on that, to sort of like, map them against each other.
The identity to me doesn't have anything to do with physics, because in my system, there isn't really an ontology. And to me, on identity is something to do with ontology. So that would be something that would possibly come out of philosophy, but not in a scientific sense.
But how is that defined then?
How is what defined?
Like, where are you? Like, okay, you have that physical body, right?
Yeah.
And we have the sense of these physical bodies. I mean, they interact with an external world, but there's a very strong sense of autonomy to this body this bag we hang around in,
Yeah.
And but this bag that we have is actually an apartment building, and it's got like dozens, thousands, bazillions of inhabitants who also get to vote on what goes on in this building and how our building behaves. So I'm just like curious how that plays into your.
We're already getting very deep right now. We have to hold on off on that. We'll do one thing.
Well, it sounds like you're asking me to account for the subcomponents of an individual.
No, I'm just like, where does that? Yeah, I'm just curious. It's like, yeah, where are you? Like, consciousness can be expanded, and we can imagine ourselves out there. And I've been everywhere at the same time a few times. Sort of there all the time. But at the same time, there is also this, we can talk about identity. So
yeah, we can talk about identity.
It sounds like, sorry. Let me now correct me if I'm wrong, Kali. It sounds like you're kind of asking what makes us feel as if we are unique and in more kind of an individualistic frame. Like, what gives us our particular frame versus we're just kind of flowing throughout the cosmos, like all together. Is that what I'm kind of hearing, or wrong?
Yeah, like, how do you define yourself?
Why do I need to define myself?
You
There is no reason in my
Me, or
philosophy
both of
for
you,
us
it's
to
like-
define ourselves. In my philosophy, we consider defining ourselves to be a sin. Not that we think that other people shouldn't sin, because it's not a self-righteous, sanctimonious,
Okay, so you're
cancerous,
not there right now.
self-spreading. Sorry?
So you're not there right now.
Not where?
Wherever you are, like, where is yourself right now?
You're presupposing that knowledge can't subsist independently of identity, and it can, because there's no prerequisite for there to be a know or for there just to be knowledge if it's embodied. So you're going off your own worldview. So according to your own worldview, you need an identity theory to make sense of things. According to my worldview, you don't.
I think the issue we're running into here, and I could be wrong, correct me if I'm wrong, Jen, is you were very direct and open. You're kind of coming at it from more of kind of like a faith-based perspective. So, Kali, when you say you, I think you're kind of talking about as a particular observer, as a particular observer rather than an individual in and of themselves. So perhaps, Jen, what are your thoughts on reference frames for observers? Is maybe an easier way to
They're
try
based
to...
on a fallacious notion of a mathematical universe, because space and time are emergent, so that stuff can't happen in space. So the thing to remember is that based on Heisenberg uncertainty principle, space is something that comes about from interaction, because delta x, delta p is greater than h bar. So bringing about a delta x co-arises with a delta p. That means it takes energy to make space. So space can't subsist on its own because the universe minimizes energy. So that is why a reference frame of an observer wouldn't be a coherent concept in my worldview. The observer is a reference frame.
Okay, so the observer themselves. So what you're saying is...
And if you want to account for unique identity, like the apparent uniqueness of identity, is that perspective relates to itself primarily. It doesn't relate externally primarily, because you have impressions, and then you have your judgment of your impressions, and then you have your first memory of your judgment of your impressions, and then you have along the line the internalized memory. It's just dinging down like a pinball machine of your own funnel of perception, if that makes sense.
I'm imagining the golf ball thing.
But where does that funnel lead?
It doesn't lead anywhere. It's just a model for your own consciousness to explain why we shouldn't expect that the objects of mind
so there is
externally, because our cognition is entirely internally derived.
Everything else is consciousness.
What are you going? Sorry, what were you going to say, me?
So there is your own consciousness separate from the rest of consciousness.
I don't think
you described it as this funnel.
Yeah, that would be a perspectival funnel. And if you want to call that separate from everything else, you can, but it's still receiving stimulus from everything else. So to call it separate sounds
kind of like an antenna, or maybe like a radio dish, or some parabolic, or whatever shape we would have. I mean, we have our eyes, we have our senses.
Yeah, we have like all the signals outside which are going around, like light and everything, and food and everything, and then they come to us, and then they just swirl downwards, and our own mentation, cognition, etc. creates this situation of self-reflection, and that's what comes into being as a sense of identity.
We got a lot deeper real quick than I was expecting. I think
it's good to go to this. I think it's actually good to get to this point quickly, because the way I'm looking at stuff and the way that atomists look at stuff is completely different. So the quicker we can force that divergence of thought to the forefront, the quicker we can realize, like, okay, it's not just nonsense. It's a completely different cosmology that leads to a different logical treatment of the empirical data. Like, that's what I was saying before with Western science. It's hard to work with Western philosophy because there's such a high importance placed on individual perception. But there's no justification for it.
Well, I like how you kind of, maybe this is deep lore. I'm not even sure if we had started the stream then. It sounds like we're kind of getting to that like Kolmogorov cascade or something like that. It's like, if all of a sudden we can get over and hit that bend at one point, it's like, okay, well, let's figure out what's going on. I think once that happens, it's probably going to happen pretty quick.
Right. Well, let me ask a question. Something happens to a car outside in the parking lot right now, which you can't perceive.
Okay.
How is that? Like, that is part of yourself, yet at the same time, you are not in no way connected to that in any perceptual way. Doesn't that effectively isolate you?
It depends on your worldview. It depends where you're starting epistemically. Like, if you was like, my worldview derives from metaphysical parsimony considerations exclusively. So there's only one mind. So everything is happening within a cosmic mind. So there's no technical or physical reason why everything couldn't be connected. That doesn't mean that everything can directly access everything else as a matter of fact to know its exact state, because there are limitations on that, brought about specifically by these physical bodies, which do appear to exist. They appear to exist.
I need to get you and Tyler together, just because I'm hearing so much of the same stuff, and I'm just thinking, I'm like,
so this is my point, is that your sense of self, which you identify even with a name, it's like, why do you even have a name? Because you separate yourself from the rest of the universe. You don't just say, sorry, I don't understand this name idea. Because you do.
Well, you're making that claim, but you can't establish that you know anything, because language can't establish knowledge in my worldview. So it's just a matter of what it is you're defining your things relative to. If identity is A equals A, then
okay, if we want to do like ontological discussion for the whole day, we could do that. I was hoping to sort of like get this onto physics something.
Mm-hmm.
Is that
this relates to physics because physics is derived from axioms, and axioms come out of non-dualism as well as other systems. And I'm here to say that the axioms that are currently being used in Western science, most of them won't work. So I'm just wondering, maybe if Memes, you have any idea of which axioms we should get rid of in order to progress forward as a wonderful, loving, worldwide, harmonious, super califragilistic, wonderful society.
Okay, how about instead?
I mean, that's why I invited you ladies here, just because I was looking for, I don't have the answers. I was curious. Oh, I think
section of that thing.
Golly, you're breaking up a bit there.
I can't hear you either. Like,
oh, you're back.
Everything you said, we didn't hear, unfortunately.
We just missed like the last 30 seconds.
Okay. I just want to say, it's like, I mean, the thing is, fundamentally, philosophically, we are totally in agreement. I believe there's only one thing. There is the universe, and it is everything, and we are sort of like parts of it. And as I always say to people, it's like the sense of self is like a delusion of changes in density. It's like, because energy is constructed in a way, you get confused and think that you're actually separate from things. But you can't ever be separate from things, because there's only one thing.
I'm going to make a claim. I think both you ladies agree on the vast majority of things.
That's the thing I'm trying to say. It's like, I think fundamentally we're coming from the same, there is only the one thing.
Well, we're definitely thinking about the same things in a similar way, because I've read what you've said in the chats, and we think about fundamental cosmology, both of us.
So what's driving this flow? I know I jumped off there. I jumped into the deep end of the pool. I don't know where it's going to go. Yeah.
Well, ask the question. Did you want to try to answer? Is there any tenets of the Western paradigm that need to be jettisoned because they're incompatible with the progress of science?
All of them. We can start from fundamentals. It's like, listen, all of my neutron decay cosmology came out of me sitting there going, what are the essential actions? There's expansion, there's contraction. The motion, linear motion, is like, yeah, that's kind of irrelevant, because you just aim it in whatever direction. That comes as a sort of secondary thing. What are fundamental principles? There's having a sense of location, which we sort of weirdly have, each of us, which is the most interesting thing about the universe, I think. that
So
we get to have
Yes,
perspective.
I actually use the fact that it feels like we're at the center of the universe. Like everyone feels like they're at the center of the universe. I called that evidence for God.
That's the thing. If
Oh,
we're all at the center
just
of the
got that.
universe, then really it's like there's only one of us and we're it.
Oh, we're getting hyper rural shout outs and everything. Thank you, Upcycle. Much
Okay, so we have someone in the chat who, Rick DeWitt says, jettison the idea that space-time is a woven fabric, IMO.
ooh.
Yeah, I think that's a good idea. We should look at it in a quintessence model where you have space-time. Do you know the other three memes?
Oh, space, time, charge, mass, temperature.
Nice one. So if we go to a quintessence model and a hierarchical emergence approach, where we're saying, well, this is the thing that's there first that can subsist in the absence of the others. And then these are the next level of emergence, and this is the next level of emergence. So we have this cluster F of other co-emergence, so we have to sort of parse through later on. But if we start with quintessence, then you say, okay, matter is quintessence. Fuck it. We're going to make the emptiness bros seethe. And then we say, okay, space-time is an emergent property of quintessence. And then space-time's not real. It's just dependent fully and an emergent property of quintessence. So that means that you can't make space-time without also bringing in its, crazy three siblings, mass, charge, temperature.
Yes, without attributes, you aren't.
So here's a completely crazy thing from the realm of mathematics in like a 7-year-old Vsauce video. Apparently, there's this thing called the Banach-Tarski paradox or something. That's that thing. You can take a ball, and if you go across it in a particular way, as long as you continually change your path, you can take one ball and then make it into, I think, 4 other balls as well, and then they all technically have the same area volume. Like it's something crazy within mathematics. And all I know is I heard that, and he's like, whoa, but as far as we know, at least within our realm, we can only chop so far. Yeah, and I don't know. That just struck me. I don't know what it means, but I don't know. Generally beat into my head that circles and spheres are really important. So
it means there's a problem with math because matter is subject to conservation principle. And if we want math to have any kind of possible connection to physics, it has to also abide a conservation principle. And that's one thing I was going to mention as an issue with the current way we understand physics, namely mathematics, is through the infinity. We have a concept of infinity that allows things like the Banach-Tarski paradox to be theoretically possible.
It's a cheat, though.
Could you possibly elaborate that a little more? Because I'm not actually familiar with, I know someone pointed out to me one time, but I'm not exactly familiar with the exact step of the reasoning in that paradox that makes it problematic. So I don't know if you could elaborate a little more.
Yeah, I consider it seriously problematic, but it comes down to continuous and non-continuous. That's essentially the fundamental problem, is that Western physics believes in some kind of discreteness or something, which may exist at the Planck level physically, but that is not to say that within the volume of a Planck there can't be a volume, because a drop of water has a whole bunch of molecules inside of it, even though it's a singular drop of water, if you know what I mean.
I'd say Jen likes drops of water.
But the Banach-Tarski, right? Sort of the idea is that, okay, we're going to take, there's infinite points on a ball. We're going to take half of infinity, which is still infinite number, and make a ball out of it. So now we've got 2 balls, and they both still have infinite points. But my thing is, well, for each point that you name on one ball, that point does not exist on the other ball, because you defined it by saying, oh, it's like, let's take all the odd numbers. Basically, it's that idea, right? It's like, well, we can separate the odds from the evens, and they're both infinite, so it's infinite.
one way we may be able to kind of skirt around this a little bit is something I got from Professor Wolfram, is that within his concept of the Ruliad, basically the minimal, whatever that may be, he calls eames, which by definition are pre-mimetic, so I'm totally okay with that. But basically, they're atoms of existence, an atom of existence, atom of space, whatever it is. And what what was proposed is each atom of existence has a unique user ID, essentially a UUID, in that it might have a unique thing. They might essentially be the same thing, but if you were to try to track the Rulial space of all potential, whatever it might be, if you are trying to run that computation, you would need to have a UUID for each one to see how they are affected by the system and to keep track of things. Is that?
Are you saying under a computational model, it's not a paradox anymore?
It kind of sounds that way.
Oh, that's interesting.
Well, yeah, but it's because you have discrete elements. You've defined your universe as being made of discrete elements.
So can I just read this one paragraph? Because I want to read this one paragraph, and then I kind of maybe realized something. I think I maybe misunderstood this, but it's from our friends at Wikipedia. The Banach-Tarski paradox is a theorem in set theoretic geometry which states the following: given a solid ball in three-dimensional space, there exists a decomposition of the ball into a finite number of disjoint subsets, which can then be put back together in a different way to yield two identical copies of the original ball. Indeed, the reassembly process involves only moving the pieces around and rotating them without changing their shape. However, the pieces themselves are not solids in the usual sense, but infinite scatterings of points. The reconstruction can work with as few as 5 pieces. I think that's pretty neat. It's but to basically try to weave it in, because basically when Jen was talking about if we're attempting to have a minimal realm of persistence, what we may colloquially refer to as universe, we seem to be able to do that with the 5-dimensional ingredients of time, space, charge, mass, and temperature. And if we're going to kind of go by the whole like principle of least action, or we're trying to minimize for something, whatever specifically that might be, because language is limited, so I'm doing my best here to be as less wrong as possible. I don't know, that's what kind of just it gets in my craw, and I'm like, I don't know why, but I'm like, I'm like, okay, so if everything, because the interesting thing about like a sphere is, what is it, a circle has the minimal area for a particular radius, and then has maximal volume, something like that. I might be reversing those.
Maximizes volume per unit area, dear.
Okay, thank you. Okay, so it has a minimum and it has a maximum effect, and I'm like, or attribute, and I'm like, that's very interesting. So if I'm going to imagine just a hypersphere, just something doing all this in my mind, infinite, whatever that might mean, or just trying to conceptualize that whirling around in some perfect sphere, maybe just completely just bright light, because light is white is all the different colors combined. If you have something like that and you are trying to decompose it, could it be decomposed into those 5 things? Is it made up of those 5 things, or would there be an inversion going on there?
What's hard to imagine is that nothing exists, and then those things come into being in a dependence relation. So there's no interference, and then there's some interference, and you get quintessence immediately. You have to mechanically separate quintessence with energy in order to be able to measure its individual 5 components. Someone in the chat, Rick DeWitt, I think, said, get rid of infinity. Or wait, no, sorry, there was another one here.
We may allow unlimited finite discrete pieces, but not infinite pieces. Okay.
Right. So getting rid of infinity, there is a school that wants to do this. And I don't know if you know the YouTube channel. The guy is like some sort of math professor, and he writes, he's like, skeptical of infinitism and whatever. Anyway, I think there are problems right now, which we point out. Banach-Tarski paradox, without changing the underlying mathematical paradigm, this is a problem with infinity. And then we could say, okay, well, whatever, let's just do the antithesis and jettison infinity entirely. I don't think that works because the universe it's useful for us to think of the universe as infinite. So if we don't have a label to put on that property, quote unquote, of the universe, it's problematic if we want to have a good correspondence between mathematics and physics, which I think is really necessary for the stuff to be useful and worthwhile. So we need to have a way of understanding infinity that is consistent with physics, and I have devised such a method, which is to begin with infinite motion and then conditionally reduce that motion through interferential observation. So the only real drawback here is that it's harder to visualize infinite motion, because right now what we're looking at is a composite atomism model, which is like, oh, there's a bunch of molecules and atoms moving around, vibrating, and something comes out of that. Whereas in my model, you'd be looking at a universe starting at the level of the universe and then conditionally reducing that with as few steps as possible to have a coherent whole. So I do think you need infinity, in short, to account for motion in physics, because you can model motion quite effectively as damp-driven harmonic resonance, and to have it be driven, there needs to be an unending source of input of that energy, which is an infinity of a kind. So number one reason for infinity, physics. Universe, infinity of a kind. Other infinity, motion. Unending universal motion. We need infinity of a kind to understand that. The question is, what kind of infinity?
It's a good question. And speaking of physics,
so
go on.
Okay, so I really think if you haven't watched already, Jen, you should consider watching one of my videos, because there might be two that say the woo and why. Because it addresses like sort of like a physical principle for why we all have this really deep sense of spiritual unity as a pure physics concept, as why. As basically, there's a Planck particle in the center of the universe. It is the highest density. It is everything. Expanding out slowly from everything is less and less stuff, because it gets less and less dense the further you are away from it. And then you're in a deep void and there's almost nothing, but there's still lambda, right? So if we look at the world this way, gravity is us getting sucked via Bernoulli's principle, essentially, because the Planck particle is sitting there spinning at C, pulling everything towards it, because the surface pressure is actually very low because it's spinning. Everything is falling towards that point. That point is event horizons. All event horizons are just that point smeared out, because singularity is a weird idea, and you can have as big a singularity as you want, but as long as it's contacting with each other and continuous, it's singular, if you know what I mean.
Jen beat my head with the whole. It's like singularity and black hole are not necessarily the same. I was using words very carelessly, but I do want to.
Yeah. There is no inside. That's the thing about Shirley's surface, is there is no. You hit the event horizon, and now what was the most dense point immediately flips and is the least dense point, which is how there's this illusion of infinity by extreme, basically. The event horizon is 0 on one side and infinity on the other. It's the point where on an equation, let's say you just do theta squared, right? Or is it sine theta squared? You get a wiggle, and it gets higher and higher and higher and higher frequency until it's in theory infinite frequency at that one last point. But that there is a limit there. The Planck is a limit. And now you flipped, and now you're on the other side of the Planck. So it seems like you moved really far, but actually you didn't, because you're just aimed exactly 180 degrees from where you were a second ago, if you understand the topology. And this is how Shirley's surface sort of solves this whole like conundrum. Also, renormalization in physics, because you go to maximum, then you flip and you drop infinity, and you only keep the little bit that you're now sticking out because you went past infinity. But it's because you got folded in and now you're inverted.
Is it possible you could show us some of the stuff on your iPad to help us conceptually? Because I've watched a fair number of your videos there, so I think that might help. But before my brain completely lags out from being overstimulated, I just want to address Surreal Physics. Thank you for joining. And what they're saying is, in the axiom of if the axiom of choice is applied here, we're saying boundlessness is bounded. So there may be a logical problem. I'm going to make a claim.
That's not the only logical problem in math. It's zero is a contradiction because it's an amountless amount.
Well, there's different types of zeros apparently.
Yes,
every time there's a problem in math, you can trace it back to a contradiction like that. It's actually kind of interesting.
There is no nothing. That's the whole point. Right outside of nothing is everything, because everything wants to be where there's nothing, but it all gets trapped on the surface because everybody's trying to be at nothing at the same time, but you can only scrunch up so much.
I want to also just touch on what Carr is saying here, because like I spent some time, probably just basically just being alone and just thinking about some of these things. I'm like, what's like a minimum of stuff? And actually, shout out to some of my friends at the Demystify Side podcast there. Full disclosure, I shoot them a couple of bucks. Cool cats. But one of the things they said,
so
basically,
if Jen can see that,
basically to have a minimal universe, you need to have at least two things. You need to have some contrast there. And I'm like, you could have all light or all dark, but for us, we're kind of contrast-based creatures. We need that gradient level there, because if we don't have that gradient, like we're just blinded, or we can't see anything. We can't identify anything else. So we do need that contrast there. I'm sorry, Kali, you were showing us some cool stuff.
No. I just wanted to show Jen. So
let me embiggen it.
There we go.
Okay.
So this is essentially the best way of thinking this is, it's a sphere that you push the poles in, but then they reconnected weird in the middle, so that when you're on the top and you go down, oops, it's really hard to do this, you're now on the inside. You were on the outside, but once you cross that barrier, you are now on the inside. And this relates to some.
Oh, I think
energy to make things.
We're breaking up a little bit, Callie, but to my knowledge, the conceptualization of Shirley's surface is basically that's a single-side surface. You're basically, given the flow diagram, it's going from the outside to the inside. I kept hearing that, and then the last one of the last times I was at the monastery, I was saying, I'm like, oh, that sounds like what Kylie's been saying. He's like, what's she been saying? It's like, well, it's a single-sided surface. He's like, she's right. I'm like, okay, I need to pay more attention to different things. Because it's like, and that's why I'm like, I'm hearing all these different things. Because I remember one of the things that Jen was stressing to me is, if you're going to try to conceptualize something, think of like, you were bringing up like raindrops and stuff like that. And like, why is a raindrop a thing? Like, what's going on with that boundary there? Like that little membrane and stuff like that. And there was a couple of, I think, semi-viral videos on the Twitters and stuff going around, but it would show like a very small needle just dropping a thing of water, just, I don't even know, maybe like a centimeter down.
But the tiniest hole,
and it bounces off. And
oh, but yeah, but this is like essential to the concept of the Planck and scale. Because in a way, when you, no matter how fine your tube, when you start to make a drop, there's a size of drop it will make under given gravity and pressure. If you're in space, you could make a gigantic drop. When
I
there's
saw
no
that.
gravity at all, you can make an infinitely big drop. As soon
I
as
saw.
gravity starts to push, the surface tension sets a new limit, and it keeps on shrinking, and it gets smaller the closer you get to the Earth.
I just remember I was watching an astronaut on the International Space Station eating some honey, and what he did is he just takes a piece of bread, he's zooming in and out, he just takes a thing of honey, just goes bloop. You just see a bloop of honey there. He zooms back out. He comes along with the bread. He folds it over. He just starts eating, and I'm like, that is so fantastic. It happened to work because I think it was also very high viscosity. It's high viscosity is more sticky things, right? But I'm just looking at that, and I'm just like, that is so freaking neat. And it made me think of that because I'm like, you have to be careful, at least in a space station, if you're doing water and stuff, because you don't want all that
No,
spray
yeah.
stuff going there. You don't want to overload the system when you're when you're that far away. But no, I just think that was where was it? Oh, okay, the slow-mo guys. That's who did it. Okay.
So is it a particle in the way we would tend to think of a particle, or is it like a non-local particle? Because to me, Thad's thing, the hyperbolic complement to the figure eight knot, that's kind of a non-local particle. I would call it an atom, but it's. I mean, if you want to get jiggy with it, you can call it a number of things. But would you see what I meant when I said it's a particle?
Say that one more time.
Thad's thing, complement, hyperbolic complement.
Right.
It looks
Oh,
like
that's
a particle.
not what that was, though.
It looks like a particle. No, I know.
It also looks very coincidentally a lot like Shirley's surface and everything too.
Yeah, it does. That's why I was thinking about it. But do you agree it looks like a particle?
It does look like a particle.
But it's not localized. It is that which localization takes place. Sorry if I flubbed the English there.
Oh no. I think Surreal's kind of summing up some of this. We do a great job at approaching circles and spheres in the universe, and it continues to be a gorgeous unifying idea we can join together on. So I mean that's because it's something that we can actually like try to compute and at least try to hold in our heads. Whatever's actually going on, I'm pretty sure that it at least they gave out whatever it's worth a Nobel Prize for basically showing that it looks like where we exist doesn't necessarily information is not necessarily localized, and that was pretty cool. I remember I brought that up when Stephen Wolfram had popped on the channel. I go to Wolfram Alpha and I'm like the minimum limit on quantum information, and he's like, that's very interesting because I mean he's a smart guy, but he doesn't know everything. That's why he created Wolfram Alpha and Mathematica, so he could actually try to figure this stuff out. And I remember it came up in the discussion with him and Jonathan a little bit yesterday because apparently there's a maximum on the entanglement speed of quantum information, so to speak. So I'm just like, I don't know what that is. I mean, that actually sounds really, really freaking cool. I should probably look that up. But I was doing rain droplets. Hold on, sorry. But window. There we go. So when big in this, let's get some thoughts and see how do we make this big. There we go. All right. Here. I've not seen this video yet.
Yes.
Is that 2,500 frames per second?
How much? 2,500 frames a second?
Yep.
Yeah.
Normal.
It makes more sense if you realize it's just a thought in God's mind.
Yeah. No. Well, yeah. I think it was just like it's just one Planck rotation.
I didn't say it, guys. I didn't say it. I'm also not going to deny it.
1 Planck second of everything shifting at little tiny bits.
All right. Cool. Oh man, I think they used the later part of that video, but basically you just kind of see it. It's like going. It's like, why is it going there? It's like there seems to be like a membrane on there, and then there's like Jen was saying, it's like whatever basic things you start out with. It's like, well, eventually I try to avoid using the word emergence. Maybe it was just because Professor Carroll says very often people that just use the word emergence just kind of.
It's just like metaphysics.
There's
There's so many people who are just saying complete gibberish in that domain that a lot of us are just like, fuck it. I don't even want to use the term.
Well, I mean, even, and this is the thing. I have my personal thoughts. It's like I try to. My dad, God rest his soul, he was an attorney, so I try to follow the evidence, and the best evidence I see, and I see and have been blessed to talk with a lot of smart people who are here now, who may be watching now or temporally in the future, and that's why I thank people, just because it's like I don't got the answer to this stuff, but if I talk to enough smart people and kind of just see where the evidence, so to speak, leads us. Maybe the evidence is wrong, but it's just there seems to be a path available right now, and I think this is a really exciting time. And I think I think we're going to be able to figure this stuff out and everything. Now, will we be able to solve all of humanity's woes in the next 15, 20 minutes? I doubt it. I'm not saying that we can't make progress, though. That's going to be my claim there, just because I try to be an optimist as well. But any thoughts on membranes, boundary conditions? What's going on? Is that why we kind of feel like there's something, Jen?
Yeah, I mean, we can't solve the boundary problem, and by the boundary problem, I mean we can't establish where boundaries exist.
Can you say more on that?
It's something you can discover for yourself. It's just a basic epistemological fact. All you have to do is look at your own perception, okay? Focus on an object, the most real seeming object, and then if you just focus in on it enough, it's not going to be having a solid surface. So you can't say that material objects have boundaries. Because not only do material objects fall apart over time, so they don't have internal subsistence, but they don't even have a solid, a fixed boundary.
I think there's a physical characteristic that gives us this illusion always, though.
Absolutely, and it's called individuality. So you're absolutely right. I mean, to deny that would be to deny a very fundamental part of the human experience, I think.
No, I mean, like, why we think a thing is a thing.
Because we have individual consciousness. Individualism co-arises with the possibility of infinite diversity of concepts. They're both appearances. They co-arise. And appearances aren't nothing in my worldview. Like, universe's quote-unquote simulation, the appearances are what is simulated. So it's important to know what it is that you're a part of. It's just something being impermanent doesn't mean it doesn't have any importance in the system. What's important in this line of thinking is that you can establish this for yourself in your own perspective in a way that, you know, seems mind independent. Boundaries are not something we can establish epistemically. And so empiricism has a problem delineating a boundary, and you can summarize that in the observer-observation dichotomy that science still can't do it, and it just says, well, we're just not going to talk about consciousness, therefore observer-observation dichotomy is irrelevant. But because consciousness is primordial, it keeps bubbling up in different things like quantum mechanics.
But I think there's actually a very specific geometry which creates the illusion of
oh no.
It looks like Callie froze.
I know reality is on to us. It's like she was about to just reveal what was going on. It's like, I believe there's a geometry, and then universe is like, no, you shall not reveal it yet. I'm sorry,
yeah,
Callie,
there's not.
Reveal.
No, but I think there's a particular geometry. I think the whole thing is about the vectors being 90 degrees to the observer. That is the thing. This creates a boundary surface that, because it's the perpendicular, this is like that is what gives us the illusion of all membranes, including our like the self that we create with our nervous system, because there's an electrical surface that is all connected, and that thing, whatever shape it takes, is the you at that moment, and it's like constantly morphing, but is a single continuous surface, and that's an electrical charge moving at 90 degrees to the surface of like the membranes that it's interacting with. If you get what I mean, if you study water dynamics, there's this thing called the Marangoni current. And it just happens. It's a weird physics thing that seems to be super innate. It's what creates this weird boundary layer of water that's pristine water, one tiny sliver of pristine water always before there's any junk. And it has to do with charge, etc. But I think there's actually like a physical cause to this idea of self. Yeah, Marangoni and the Marangoni current. And whenever you have two layers, you get a Marangoni current in between those layers.
So
Can you watch the video?
Oh, yeah. All right, so they're adding pepper.
Oh yeah, it has to do with no surface tension.
Whoa! That what? 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 Hold on. Wait, we're playing that again. That just semi blew my mind. All right, so you're adding it there. So there's something with tension. What is the other thing? Is that just water?
Surface tension. Superfluid.
Huh.
Relatively speaking.
That's well, I was not expecting that. Let's oh, where are we? Let me add this back. Oh, where are we? There we go. Huh. So at least according to our friends at Wikipedia, I also have NASA up here, so we'll jump into that. The Marangoni effect, also known as the Gibbs-Marangoni effect, is the mass transfer along an interface between two phases due to a gradient of the surface tension. In the case of temperature dependence, this phenomenon may be called thermocapillary convection. Huh. That's very interesting.
And the Marangoni current comes in when you have two layers like this. Because the surface tension is clinging to sort of both of them, it creates effectively almost like an anti-de Sitter space between those membranes that allows exceptionally fast passage of things because it's running counters everything.
Huh.
You might have to put Marangoni current. It's usually applied to cell membranes because cells always have like these dual lipid layers.
Well, as soon as I heard thermocapillary convection, I'm like, that sounds biological right there. So it's
But I think this is what gives us this illusion of, and all things like, why is this a marker? Is because along the surface here, all these electrons are clinging to the surface and traveling along here instead of just flying out all over the place so much. Why is a gas hard to define from another part of the gas? Because it's just flinging itself out so far that it's got no sideways motion. It's all, you know, it's diffuse. It's chaotic, stochastic. This is not anymore.
Oh, the spelling. Hold on, I got the. Oh, let me get my autocorrect going. I believe it should actually be this, Rick. It should be Marangoni.
Almost the way we construct our identity in a way. We give ourself attributes so that we can construct a sense of self, because otherwise, if we had no qualities at all, then we would hardly be able to figure out who we were.
My brain is getting pretty laden with a lot of things and a lot of homework. I already have enough homework, but this is fun. So okay, sidetracked. My mind's already been blown a couple of times. So let's keep going. You were
I want to hear more from Jen, though.
Yeah.
I do have a screen share if you want to share.
Oh, okay, yeah. Let me start mine. There we go. Oh God, I was ignoring you. Sorry. Here we
It's
go.
all good.
I'll embiggen it. There we go. Cool. Take it away.
So yeah, we have the hyperbolic figure eight complement shape. And yeah, so basically back to this idea of boundaries, like we can't establish boundaries on the absolute level. We can establish them locally, we can establish them apparently, but we can't establish them absolutely.
Oh,
So
yeah,
then we have,
no, of course not.
We have to ask, what's the utility of boundaries? And it turns out that it's a condition for coherence for a lot of the stuff that we think about. So, for example, a concept, part of a precondition of conceptualizing a concept is that there's a boundary between it and other concepts. Separation is the basis of identity, and more specifically, the appearance of separation.
Appearance of, yeah.
Right. So we have the appearance of separation, which is where the Western science people are saying, well, let's put the boundary on the appearance of separation. And I'm saying, sorry, I meant to say the epistemic boundary. And then I'm saying that doesn't work, but go ahead, Memes, what were you going to say?
No, it sounds like you're saying we've been focusing kind of on the wrong thing. Is that what I'm, or
in a way, we've been focusing on the right thing. Like it does. I mean, we got to the periodic table.
Okay. So is it our interpretation of what we've been focusing on?
It's just incomplete. Like the periodic table is not wrong. It's just incomplete. And then when you see, that, oh, okay, the periodic table isn't actually, it's just one object and it looks like this thing on the left. And actually this thing has infinite motion. So all of its constituents are moving at infinity speed at all times. And when you move these 59 balls at infinity speed at all times around the center and interconnected with the balls of the same color, you end up with this shape here, the hyperbolic complement to the periodic table. I just want to make sure this, okay, hang on. It's,
yeah, I still have issues with this figure eight knot, but whatever.
Sorry, can you reshare? Okay, hang on. I didn't, looks like
Collie, I'm going to make a claim. If you add enough rotation in there, that center to Shirley surface is probably going to do something like that. That's why I just you coming to that from just pure geometric interpretation.
My issue is that the figure eight complement knot is not a surface of least energy anymore. There's that twist in the center is a tension, and a tension means you need to force an energy. Yet all you have to do in this universe is fall. Just keep falling, and you'll just keep falling and fall and keep falling, and then you fall some more, and you fall, and then you fall. You never need to get pushed. That the twistiness is a high energy. The energy is the same. Nobody needs to work. The sense of energy about an event horizon is a relativistic thing. It's because we're way out here where there's lots of spaciness, and relatively down there it seems compressed. But locally, everything is always the same.
Are you saying this can't represent subsistence because it's too complicated?
Yes.
Well, that's like saying the periodic table can't represent subsistence because it's too complicated.
I'm just saying that shape does not make sense to me because you just fall, and that shape has that convolution in the middle is like
Kali is not convinced yet on our conjecture. I would conjecture that twist in the middle is what helps bring it into the minimalness there. Again, I am completely biased on this.
Think of it as a representation. As what's the simplest way to represent 3+1 dimensions? Because you're not taking into account that the ambient situation is not without complexity, e.g. 3+1 dimensions.
A 3 plus a compactified dimension.
Well, Kali's thing is basically time is compact. I'm still not 100% sure what you mean by compactify. I'm not going to disagree with it because I don't know what you mean, and
She's basically saying
fits in a Planck second right now. That is all.
Okay. I mean, I'm all right with that.
She's saying that this model here is too complicated, basically.
Yes, we can eliminate one of those twists. We can eliminate a dimension. Time is not a scalar by any stretch of, well, it's by a stretch of an imagination, it is, but it's not. Time is compactified, which is why trefoil, everything, 3 forces, 3 neutrons, 3 charges. Well, not 3 neutrinos, 3 sides to a neutrino, let's call it. You know? That is the artifact. The time is an illusion. We don't move around in time. This whole notion of a time, like, what? There's now.
Kali, give me 6 months and a lot of time with ChatGPT, and I'll come back to this with you. I'll do it in a way that if I can convince you, I think we're good. But you believe at this time it's not necessary. Let Jen go through, explain it. Maybe you won't change your mind. Maybe you'll be a bit more open to it. So, Jen, you mind?
Okay. Yes. Continue though. Continue. Because I think I get it. Basically, this is like Shirley's surface, only with an extra twist.
All right. So basically, you're looking at a model where fundamentally it's non-dualistic. So there's no independent observation. So every observation co-arises with its observing device. And so you want to ask a question like, well, what's the basis of this observation? What's the foundation of this observation? And of course, it should be metaphysically parsimonious. But then there's a question as to what exactly is metaphysical parsimony. I mean, if we're just going to say everything is conditional, that's not really ready to be a law of physics per se. So we have to go further than that. So we want to say, well, taking out the conditionality, there's a fourness that subsists in absence of the conditionality, which brings about the conditionality. And this fourness is embodied by the figure at the left, which is a quantum periodic table, but is also embodied by the figure behind the magic apple, which is the hyperbolic complement to figure 8 out. So thanks to Thad Roberts for discovering that, because it's the they're both dualistic because they're a boundary, and that's fine because it's conditional on observation. And so this would be the fundamental conditionality, is the condition of observation. And the boundary within which that takes place are the shapes corresponding to what it is that makes life forms and what it is that makes what makes life forms, which is the quantum periodic table. And then life forms themselves are deviations of this shape here, the HF8C, I call that for short, the hyperbolic complement. And so it's got a very, I agree actually, and I'm glad Kali brought this point up, to be honest, that it doesn't appear at first glance to be parsimonious. But that's because we don't exactly have a sophisticated notion of parsimony, because a lot of stuff we're told is parsimonious is just kind of like presented as parsimonious. And you can see why maybe it's parsimonious in that context, but the context itself, why should we care about that particular context bringing out about parsimony? It's like I could invent a million contexts where I say something like A equals A, but the parsimony condition is really only relevant when you're actually talking about something that could eventually be empirical, e.g. science. So yeah, that's, I think it's a stronger model. So anyway, back to this parsimony thing. It's parsimonious on the level of there being 3+1 observables. So it's not parsimonious if there's one dimension in the universe. It's not parsimonious if there's two dimensions in the universe, but it is parsimonious relative to the number of dimensions that there actually are in the universe, which is 3+1. So it represents fourness as a single shape. All four aspects of it kind of spread out into a fifth dimension, which is the surface itself. So that's why I understand why it seems like it's not parsimonious. So it's, arguably it's less parsimonious than a circle, but a circle doesn't have physical correspondence. Whereas this has physical correspondence because the observables like the quintessence in space-time are emergent from this shape, not just in the formal technical way that that is deduced, but also in the literal way that the shape of our bodies can be ascertained through a composite deviation of this fundamental shape.
And just to clarify, one of the reasons why I'm very impressed with Kale's work is she basically just kind of sat back, was just like, well, what's the easiest way to go about this? Thad came across this just because, hold on, let me share my screen. A very particular number kept popping up on Wolfram Alpha. So let me just do this real quick. Just one moment, Jen. Basically, within this is for the figure 8 knot within mathematics. It has a defined volume, that 2.29 and everything. That was how he had come across it. Is because when he was doing his work, a particular number kept popping up that actually had a geometric correspondence. And he's like, what's going on? And he started to study it as well. And I believe, is this where, Jen, you're saying the 3+1 comes from? I'm still a little unclear on this. I remember you told me before, kind of some of the parametric equations here.
It's a logical assertion, not an algebraic one.
Okay.
So we're looking at not quite mathematical yet, but numerological. So it's a counting principle. And I'll pull up.
Okay.
Go ahead.
Pull that up. Let me. The thing that makes sense to me for explanatory power is just because under here in the number 2, and again, it's Wikipedia, take it for what it's worth. It is the link at 0, 0, 0, 0, an isolated critical point. I'm like, okay, that sounds like if I was to put all those zeros into some type of coordinate map, that kind of sounds like what people describe as a singularity, so to speak. It's essentially a singular point there of balance, and
that's not a singularity in the common sense.
You're right.
You could call it a balance point, but memes, hang on.
Like,
if you call it a balance point, you're implying that the shape is a point, which might confuse people. So I think we're really in virgin territory here. I'm not trying to say you're wrong. I'm just trying to say we don't actually have answers to this yet. So we should be thinking of this as a round table about what should we call it, presupposing there isn't actually an answer yet.
No, I don't know. That's why I tried to be. I wasn't specific enough. I'm just like, it kind of sounds like. So let me remove that. And Jen, if you have your stuff, we can bring that back up. So I mean, I'm open to ideas and interpretations because I don't know what it is. I just kind of see things like that, and I'm like, that's interesting, and I feel like it might help us figure out more about what's
okay. So the shape is technically 3+1 into 3 plus 3+1 times 3+1.
Okay.
But I just summarize. I shorten it up to 3+1 because I think it's a little easier to understand.
Okay, I'm seeing what you're saying.
So start at the center. Just put the conceptualization paradigm, put the presuppositions aside. Just look at it as a geometry and start it in the center. That's 1. And then if you go the next one to the side, there's 2 times 2. And the next one is 3 times 3. And the last one is 4 times 4, and they're symmetric or anti-symmetric about the origin. Now, anti-symmetric means that you get that green line straight through with the greens.
Mhm.
So what's the equation
Which one?
for an anti-symmetric function? Anyway, it's like f of negative x equals negative f of x, something like that. Anyway, I hope it's clear why this thing has an anti-symmetrical shape, and how you have is it just real quick?
I'm just bringing it right now.
Because if it was symmetric, it would be exactly the same on both sides.
2 seconds.
Yeah. No, it's the.
It's just a really technical. Like, I think technically what I should be saying is that it's symmetric about the origin, which is also anti-symmetric. Anyway, whatever.
Yeah. I think that's
the point is that it
different.
has a type of optimized symmetry. That's what we're sort of drilling down on here. Is that there's a symmetry to this shape, and that symmetry has to do with 3 plus 1. And so I've got like all the different points labeled here, so you can see how you get it to track to shape along all the faces. And at the overall shape of this thing, if you get rid of the circles and replace them with points, it's 2 square bottom pyramids touching at the tips. Not sure what else, like how you would call that exactly. But I call it the embodiment of 3 plus 1. So you start with 1 layer, and then there's 3 layers on the outside. But there's 2 of them, right?
Right. Because
so that means that matter is inherently
it's
dualistic.
So that, whatever angle or whatever spin, it's actually an inverted around that center point. Lower left is upper right, exactly. Etc. It's like rotationally inverted, passing through a center point. So it's like,
I am not as well read on this as I should be, which is the technical description of this thing. But yeah, basically that's the idea, is that the quantum periodic table as a shape dictates the motion of space-time, or quintessence, but I'll call it space-time just because I don't want to confuse people. So I don't think it's obvious what I'm talking about if I say quintessence.
Yeah. I mean, I think most people just think of that as like, okay, so you mean like, if they're coming from a quantum thing, then they're like, oh, you mean like quantum space with its virtual particles happening all the time and whatever. That's the way they think of it.
Yes, the things that are real but are not actually real. It's
the potentia. But this is the thing I wanted to talk about, was Jen brought up about how nothing just happens, because it takes effort, because you have to cause complexity, sort of, right?
Complexity is intrinsic, it doesn't change, but the net energy of the universe is 0. It's
right.
Like, it's not a self-contained perpetual motion system, but it kind of sometimes helps to think of it that way.
No, but this is again why Shirley's surface is a single-sided space. Solves CP symmetry, all of that, because inherently, exactly, every point has its inverse correspondence, just like that diagram, across the surface of this membrane, because one side of the membrane is matter, this side is antimatter, therefore they're always balancing out. This is my proposition for why electron half spin. There's an orbit on this side as an electron, which is in my conception, a divergence and inflow into the space, spaciousness, essentially, actually. And then, but it is reciprocated on the other side as a positron, which we don't get to see because that positron is internalized in the electron, but it's why the electron has half spin. Photon is its own anti, because it's simultaneously on both sides of the membrane and is balanced, and therefore doesn't have half spin.
Do you have
If
your
you get what I mean? This is where I came to Shirley's surface. I was like, how do I find a shape that will solve this? It was like when I was looking for root 2, because I wanted a piece of paper that I could fold in half and it would not change it.
Dan
You
L.
know?
Line in the chat asked, is the negation of real non-real? Notice, Dan, we haven't actually talked about reality yet. And I'm not being cheeky or anything. It's perfectly common to have this be the case because we're presupposing a shared context, e.g., what is objectively real and non-real is sort of tacit to the topic, as it tends to be. That's why you get frustration if you ask a philosopher to define real. They're just wading into a territory they're not used to because they're just used to the context of everybody presupposing the same trappings.
If anything or anybody experienced it, it was real.
Well, sure. I mean, we all have our like whatever subconscious
all simultaneously
presuppositions about reality. Like we all have a notion of reality, whether it's acknowledged or not, because we're interfacing with the objects that are normally associated with reality, like language, society, etc. But when we talk about real and non-real from a philosophical perspective, we have to think of it like, why are we defining something as real? Like, what does it make sense to define as real? And that's where you have to start to have a philosophical conversation about like, well, how do we want to understand reality? And with my system, it's always metaphysically parsimoniously. But we have an intrinsic, immutable complexity, which is embodied by this quantum periodic table. So it's not nothing in the structure sense. So we haven't actually discussed that. But in my worldview, for something to be real, we don't really throw that term around like my schools often refer to as non-realism. But I don't think that those types of titles really help too much when presenting it to a secular audience. So it's more like association of what realism would be if it existed, and then realizing that some form of it does exist, e.g. the periodic table is real for all intents and purposes, but we can't measure it. So the realism that exists, e.g. the permanent boundary, that's not really permanent, but it's pretty permanent, it's like billions of years old, it's not an empirical boundary because we don't have direct access to the quantum periodic table as such in a coherent sense. We technically do because we can't not observe the constituency of this thing because this is all that exists, but there's sort of some steps.
When you say we can't measure it, are you talking about like the quantum periodic table as in measuring the entire thing, or
like if someone was like, if someone
or
asked me for empirical evidence of the periodic table, what could I point to?
I mean, isn't that what we're looking at right now?
Right. So that object right there is not empirical. It's a theoretical object. So we can conceive of it, but we can't empirically establish it.
Okay. All right.
We can establish it through
as a formality or like a formal set of organizational stuff.
Oh, it's a model. It's a model. It's the model. It's the quantum periodic table.
It's a model.
It's a model of that. What gives me, I'm not going to say hope. What leads me to believe that what Jen's showing here is significant is because also I think it was either the first or second time that I went to the monastery that apparently Thad had kind of gone to the same thing, just going a different way. As soon as he busted that thing out, because Jen's thing is utilizing basically the periodic table, to our knowledge, is 118 elements. We go up to element 118. Jen has it reduced down to the 59. Thad, basically, Jen, I believe your model, you basically have hydrogen in the center and you go out from that. Thad's model is basically, he just has helium in the center and then he just builds up from there using the, I believe, domino tiling constant. And as soon as I saw that, I'm like, oh my God, we're talking about the same things here. So that was go on.
If Thad starts at helium, does he sort of count hydrogen, the two kinds, I guess the two common kinds, as like Sof and Ein Sof kind of things. Like he leaves them off because they're essentially like they're not actually a whole thing yet because there's not two of them.
That's a great question. I don't have an answer specifically to that. It's basically you start off with hydrogen, and then basically once you get to helium, I mean, maybe that's one of the reasons why helium is like, I don't know, seemingly pretty a stable thing because of how it just kind of comes together to the best of our knowledge within science
I've got
and
a good
stuff.
metaphor for you. Standing wave.
Okay, yeah. Because I mean the truth is that hydrogen is sort of like it's half baked, and that's why it's like always clings to everything and sticks to the outside of things, right? It's like you leave anything lying around, it's got some free ends. It's like hydrogen's going to bond up. If nothing else gets there, some hydrogen's going to close up on that stuff. It's like the sealant on the universe. You try and make some graphene, and it's like, oh, every single end sticking out, it's going to get hydrated, right?
Well, graphene also seems to like to curl and everything. And it just keeps on following a hexagonal pattern. Oh, kind of like a snowflake there in some ways, but cool.
I just mean like when you're making molecules, if you just leave them lying around, what happens in nature, and this is why it's like a button on most modelers, is boop, hydrogens are just going to swarm that thing and try and bond to any free charges you have. So hydrogen is, in a way, almost like not quite. It's like its very own particular kind of atom because it doesn't have that standing wave thing, as you pointed out, of the helium being two entire closures which are now confined in here. Hydrogen is just sticking out because it's only got the proton and the electrons. It's all radial. There's no closure on it, sort of.
Well, Kali, you kind of stressed this to me because what happens as soon as you pop off that electron there, you basically have, what is it? We refer to as atomic hydrogen, aka a proton.
Yeah, exactly.
Cool.
It's barely an atom.
So, well, I mean, I don't even think. Well, yeah. Jen, we've got some snowflakes. They're very pretty.
Oh yeah, I just wanted to come back to the thing about the standing wave. If you can imagine one with six loopies and 7 dotties. I'm really good with technical terms, aren't I? I'm just killing.
No, it's perfect.
You know what do you actually know what I'm saying? Can you see what I'm saying right now? It's a line, and then you make a standing wave on it. And then there's harmonics of the standing wave.
Oh, hold on.
I could launch Paintbrush and show you what I'm talking about because it's not going to make much sense.
No, I think this will. Hold on, let me share. I think this is what Kali was just starting to get a little bit excited about. Where are we? Would you say maybe something a little bit like this?
No, sorry.
Like
okay.
That's not what I'm saying. It's beautiful though.
No. But actually, the snowflake is fractalized so that every single, it's like it branches and then that branch branches and that branch branches. That's a whole like unfurling of the snowflake there.
Well, I wouldn't mind a copy of that image. It's quite nice, but that wasn't what I was thinking of. No, I wanted something just ultra simple. So I'll share if it's okay. I'll show what I'm talking about.
Yeah.
Let's see here.
No. As soon as you said that, and you said the 6 things, I'm like, oh, I literally just cut that picture earlier to throw it in the thumbnail. So, just checking. I'm just curious. But finally, one of these lowest matter binding. Oh my God, so many cool things here. I see why Professor Wolfram does this.
Okay, I'm sharing now. Awesome.
Okay, there we go.
All right, so this is what I was talking about. Like, I know my metaphors sound ultra technical, but I'm not. I am really trying to simplify this as much as possible here. So 1, 2, 3, 4, 5, 6. Okay. Did you see what I drew?
I see a wave, looks like.
Yep.
So what you want to imagine is that the line that's squiggly, it's rotating around the straight line.
So kind of like in some of those videos where they kind of like have like a photon and how it travels or something like that. It's kind of like a screw.
This is non-local. This is non-local, but yes. This example here is just a theoretical intuition about the periodic table and why we have the noble gases. So this is two-dimensional. It's actually one-dimensional, spread out over two-dimensional. But this turns out to be the easiest way for us to learn. So we bring a lot of times we bring these four-dimensional metaphors down to one plus one dimension, so that try to make it as clear as possible. It's not always clear, but at least on this level,
a point is technically, sorry to cut you off. Yeah, a point is technically zero-dimensional. A line is one-dimensional. So we're looking at a one-dimensional wave here, technically.
We're looking at a 1 plus 1 dimensional. It starts out at one point and then it goes out into another dimension. So yeah, you can say it's 2D or 1 plus 1D, however you want to talk about that, doesn't really matter. The idea is that we're trying to model stationary motion. Ooh, a contradiction. It's not a contradiction. We can have motion that's happening within a more or less stationary situation. So this is a model for the quantum periodic table, which we saw before, which is complex, 59 components, 118 elements, but only 3 plus 1 dimensions. So what does that mean? Well, it means that there's some type of periodicity to matter, and we have these deviations from stability, and then you have stable points. Whoops. You have what appear to be stable points in between them. So even if the black graph is rotating around the red line, these green points are not moving. See what I mean?
It's too bad you can't take the ends of those two ends and just, like, you know, put it into a little circle so that the whole thing can resonate inside of it.
Well, it is doing that, and this is just a model, but the model.
I know. I'm just like right now. I was saying, if you could just do that, that would be a great illustration.
We're working on it.
So this is meant to be a metaphor for the noble gases. We have an overall wave-like character to matter, and that, what does that mean? Stationary motion, which means a line and a wave going around it, swirling around it in 3D, so creating like a cage with that deviation. That swirling shape still has stationary points, and that's what's important here, is that even if you have a lot of motion, the fact that it's constrained in any way means you're going to have stationary, stable states arise with that motion. And that's what corresponds to the noble gases. These green points correspond to the noble gases, and then the yellow sections correspond to the rows on the periodic table that are not as stable as the noble gases.
So those are kind of like
dissipative.
Those are stable points, hence why the noble gases
unevenly
are
scaled there. I mean, it's
first,
fascinating. The nuclear packing, like, is fascinating.
We missed the first 15 seconds of what you were saying right there, Kali. I'm sorry.
Oh, that those were evenly spaced waves, but really they should be either there should be a logarithmic scale on the number line, or those waves should sort of dissipate, right? Like the first one is very short, but then each one gets longer as the atomic numbers get larger. There's more electrons before you get to the next noble gas. So the waveform changes its size.
Yep. And
yeah.
Do you know why?
The same way everything does. The same way the frequencies. It's like when you've got your electrons, you know, your electron orbitals and the photons you can get out of it, you know? And it's like this local scaling. It's fascinating, though. You know, you're close to the nucleus. You have a big nucleus. You emit really high frequency because you're pulling those electrons in whack fast. Your hydrogen you only got one proton. It's like, okay, I'll get around to it. And you emit 21 centimeters, you know?
Cool. Thoughts? Jen?
Awesome. Yeah, it's such an awesome discussion. I'm really enjoying myself.
This is what? Oh my God, we've been going for an hour and a half.
Yeah. I really need to do a deep dive into into the periodic table, though. Your periodic table.
It's Jen has actually a really great blog. My only issue with Jen's blog is it reminds me of the book called The Mixed Up Files of Mrs. Basil E. Frank Wilder or something like that, where it's like all this art, all these different things. Only one person knows how to really navigate it.
I'm working on that. I've been using ChatGPT for months to improve my writing skills, so I do apologize at the level of train wreckness that there is on that blog. Writing is not my strong suit, and I have internalized some bad habits from writing like other types of technical stuff. So yeah, the blog is a work in progress, but I appreciate the shout out. And the latest thing on there is, I think one of the latest things on there is pretty interesting because it shows, or it's me attempting to show how all life forms are instantiations of the hyperbolic complement knot. And that with a cell, the difference between a cell and us is that our mouths are separated from our anus. And with a single cell, the mouth is non-localized and the anus, so they're completely missable. They're the same thing. And then evolution is basically a gradual process of pushing your mouth away from your anus. So that's another huge selling point. I love that it can be so succinctly expressed.
And very memeable, because as history would say, gas is real. I'm sorry. I had to incorporate a little bit of potty humor. I apologize. This is great. This is I was not expecting this level of analysis and everything. My brain is legitimately tired right now.
Yeah,
Fantastic.
the transformation from lysosomes to having essentially the donut form that so many things have is really that's huge, because that's a topological ginormous transformation. You know, like having a mouth and an anus and a tube that joins the two. Cells don't have that. They envelop, and then they manufacture a little lumpy thing that's going to work as a stomach, like the lysosome, but it's completely internalized. There's no tube thing. There's a big evolutionary step when all of a sudden you have a mouth, and that runs through a tube that you digest it, and then it comes out the other end. Like we're all donuts, right? Like every human is a donut, really. Your mouth is one side of the donut, and your butt is the other side of the donut.
The only freedom the cell really has is the fact that it exists in 3+1 dimensions. And that's what is embodied through the pump. But when the embodiment is really slight, as it is with a single cell, the holes in that figure are non-local. So normally in the figure, you can localize the hole to a region, but at the limit, you can't really do that.
Yeah. It's distributed. It's all the pores on the whole membrane and stuff like that. It works very differently, though. That whole having a single continuous flow system is a real innovation in cell structure, or organism structure.
I need to study the Krebs cycle, don't I? I keep hearing it's so boring, but something proton channeling that cells do, and I'm like, huh. This is sounding quite relevant to the things we've been talking about. Groovy. Anything else you ladies want to go over before we wrap up?
This has been really good conversation. I hope we can have another one. Thanks a lot for the chance to talk, and it's really great to hear different opinions. And thanks for the questions, Callie, because I think as far as philosophical, as far as the Socratic method goes, you are right on top of that.
Can confirm.
And I think it was
thank
very,
you.
very
And as I said, I
useful for
really
the
want to do a deep dive because nucleon structuring is like one of my like things I still.
It's my fault. I literally, Jen had asked me, it's like, well, what are we going to talk about? I'm like, stuff and things. It's like, I said, oh, well, probably membranes and stuff like that. I'll actually have actual topics because we're
I
going to
think
get some
that's what
other
you.
stuff.
I think that's what you sent me. Actually, you're like, oh, membranes, and I was like, all right, I can.
Okay.
I can do that.
There was no direction given and everything, so it's like, okay, I kind of spur of the moment, just kind of go with the flow, just because it's like I don't know what's going to happen. It's like I've tried completely scripting things before. I have friends that they have their whole show script. We're going to do this. We'll talk about this for exactly 3 minutes and stuff. I don't know. I don't like that rigidness there. It's like if somebody's flowing, you let that person flow in it and everything. So it's just like those are when the best discussions happen. Unfortunately, well, maybe fortunately, sometimes it happens before and after the discussions. But no, this has been great. Golly, some final thoughts.
No, thank you so much, Jen. And like as I said, like yeah, I'd love to get.
Trying to do the account for the delays. There we go.
Oh, we're all getting soft now.
Say your final thoughts one more time, Golly. I'm sorry, we missed it.
I missed that, I think.
Oh, okay. No. We didn't hear what you said. You were lagging out. I'm sorry.
Yeah. I don't know what's happening.
No
You
worries.
might want to deactivate your video because we're having trouble hearing pretty much anything you're saying, and your video is frozen.
There we go.
There, we can do that.
Yep. Final thoughts, Golly.
Oh. I don't
Whatever
know.
you just said.
I
or
need
whatever.
to deep dive this periodic table. Everyone should.
Cool. All right. And both Kali and Jen's channels have been linked in the doobly-doo as well as in the chat there. So, hey, thank you all for joining now and temporally in the future for the inaugural episode of the Cosmic Council. So, here's to a better future for humanity. Hopefully we level up and we can figure this stuff out. Why? Because we can. Peace out, everybody.